Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. Ladies and gentlemen, let's continue our hourly analysis program. In this video, we're gonna complete our energy analysis tutorials. The previous video, we talked about how to define the boiler and the other things like the chillers and the cooling towers in the previous videos. So in this video, we're gonna talk about the electric and fuel rates. The next tutorial, we're gonna talk about something in the plants that we have never covered or haven't covered yet, like the chiller plant. We're gonna talk about the configuration, schedule of equipment and distribution and these things. After the next video, we're gonna we will have only to define the building to and generate the energy simulation report. Okay, so here the electric rates. Open, new, default. Okay, so here the general tab. Notice that we have here general tab. Here is the sample electric rate. You can make the name here or type the rate name here. You have two systems, simple or complex. If you click on complex, you'll find that we have here energy charges, demand clauses. So for the general and simple, if you have a simple, you don't have to make energy units, you don't have to make conversion. This is for the complex systems, and so you only have to write here or type the flat price, dollars per kilowatt hour. Okay, flat price for simple rate, that is fixed for the electric consumption. The energy here is per kilowatt hour and it's dollars. So what if you don't want to deal with dollars? So you can click cancel, view preferences, and you have here the project and the currency units. Here is dollars. You can make it any other thing. Okay, something like this. Electric rates, default electric rate. Notice that has been changed. Okay, so view preferences, project, and dollars. Okay, here is okay, no problem. Just click OK and go to electric rates again. New default, simple. So here's the flat price per simple rate. Okay, and here the customer charge. Okay, you can also click F1. So this item only applies when entering a simple type of rate, defines the flat price for energy or fuel applying to all consumption each month. So you have to enter the how much dollars per kilowatt hour each month. So the price units depend on the energy units defined in the earlier or currency defined the project preferences. Okay. Okay, thanks. So the customer charge, if you have any monthly fixed charge for the bill, you have to enter it here. Dollars. Many utilities impose the fixed charge each billing period to cover the cost of providing service or for rendering the bill. So this may be referred to as a customer charge or a service charge or a fixed charge. If a customer charge is not imposed, enter 0 for this item. Okay. Okay, here the minimum charge, also the minimum monthly charge. If you have any minimum charge that you have to pay monthly, you have to enter it here. Let's click F1. So this identifies the minimum allowable charge each billing period. If the sum of energy, demand, and customer charges is lower than the minimum charge, okay, the customer is billed for the minimum charge instead. So this is the importance of this item. So if a minimum is imposed, it will be listed on the utility rate sheet. When a minimum charge is not imposed, enter zero value for this item. Also, if you have a tax rate, you have to enter it here. Percentage taxes are often levied on electric and fuel charges. Users can account for tax changes by defining a tax rate with this input item. Tax will be computed based on the total of energy. So if taxes are not imposed for or you do wish to consider, no, do not wish to consider them, enter a tax rate percentage of zero. Okay. So here is the tax rate. It's according to the total consumption. Okay. There is no seasonal scheduling, no time of day scheduling, because this is just simple type. Okay. But we have here the emissions analysis. If you want to enter it, here is the pound per kilowatt hour. Okay, if you have to get this value if you want. So the emission analysis section of the journal tab allows the greenhouse gas emission rates to be defined for electrical energy or a particular fuel source. This is an optional section. If emissions data is supplied, the program will estimate the total CO2 equivalent, this CO2e emissions, based on the total energy or fuel consumption for the year. Results are shown on the annual energy use and emissions summary report. To get it, this data is often required for green building design applications. So this is very important to you to get this data for the green building projects. So to include the emissions calculations in your analysis, first mark the checkbox, okay, then enter CO2e emission factor, many different greenhouse gaseous emissions from the generation of electricity or burning of fossil fuels contribute to atmospheric greenhouse, okay, warming. So the CO2 equivalent emission factor represents the equivalent IB or kilogram of CO2 per unit of energy or fuel that have the same greenhouse warming effect as all of the different gaseous emissions combined. So this provides a single point of reference for evaluating the greenhouse warming effect of energy consumption. So if you don't have anything in this, you may uncheck it and then you can click OK. So we have here the sample electric rate. So what if you have complex type? Okay, notice that the only difference here is the complex. You have to get the demand units in kilowatt or kVA. What does this mean? So the demand units for electric rates, users can choose between kilowatt or kVA as the units of measure. Kilowatt is the working power measured by a watt meter. kVA is the apparent power, which includes both the working and reactive components of power. So, and this is a more complete representation of power used. However, buildings typically use watt meters, so kilowatt is more frequently measured than kVA. The units of measure for demand will be listed on the electric rate sheet and will dictate your choice for this input, okay? So, it is recommended to use kilowatt. So here are the seasonal scheduling. For some reasons or for some situations or for some countries, the bill in the summer is not like the bill in the winter. So you have to determine which month for the summer and for the winter to make differences between them for the bill. Okay, so if you here click on F1, here is seasonal scheduling, when separate energy, fuel, or demand prices are defined for different times of year, or when demand determination clauses require different calculations based on time of year. The utility rate will specify which months of the year fall in different billing seasons. Typically, two billing seasons are referred to as summer and winter are used. In some cases, a third billing season is used, mid. HAP provides an option for a third season, here refers as mid-season. So when seasonal scheduling is used, first mark it, okay, this activates, okay, and journal tab, okay, particular season to assign a month, okay, click the button, okay, so January through May, so the figure above here, January through May is the winter, like this, January, February, March, April, May, this is the winter seasons, okay, and from June to September, June, September is the summer, okay, but October, November, December is the mid, okay. So the mid-seasons option has not been used in this example for this, okay, no mid-seasons, but we have here mid-season if you want. But if you consider this for winter and they have the same price, okay, included here, so we have here summer different prices for these months, and here another price for this month, okay, and so on. Also, suppose that you have different prices through the day, okay? So here the time of day scheduling, suppose that the peak consumption or the consumption through the peak of the day has a price, and another time has another price. So you have to make a schedule here, utility rate time of day. You can make this from here, or you can here click okay, cancel, can go to schedules, make new default schedule, and utility time of day, can make here electric, simple, complex, okay, like what we did, okay, here the time of day, none. So you can select your sample schedule of if you don't have the sample schedule, you can create new schedule. So now here we have to get the utility rate time of day. Here are the hourly profiles. As we discussed these profiles, well, that we have many profiles or three profiles, one for the normal day and the other for the holidays and for the light work days. You have to make the profiles you need, and here you have to get the details. So for profile one, suppose that you have here, notice that we have here off, normal, mid, peak. According to the hours, you have to determine which hour is the peak and which hour is the mid and which hour is the norm and which hour off. Okay, so like this, here is the mid, here is the norm. Suppose that we have something like that. You have to exactly determine what you want. You can click F1 here. So about profiles, a schedule consists of up to 8 profiles. Each profile contains data for 124-hour period. Separate profiles present behavior on different days or at different times of year. So on the assignment tab, profiles will be linked to specific days of the month and months of the year, okay? So here, so the Profiles tab provides features for defining all the profiles associated with the current schedule. The tab consists of the two panels. The left-hand panel in the working area, it contains the profile name and the profile currently being edited. In the figure above, data for profile 1 here, like this is a design day, okay, is being edited. This profile has been named design day. It is a part of a fractional schedule indicated by the fact that the profile values are defined as percentages, okay? The right-hand panel is a display area which contains graphical images for all 8 profiles, okay? So we have here open the profile you wish to edit, specify the profile name, define the hourly values for the profile, and then close the profile. Also, open the profile. The profile must be open to make it active and like what I have just did here. Okay, so please, you have to determine exactly hours that you have peak consumption of the electricity and which mid, which normal, and which off. Okay, then after finishing this, can make here profile 2 and change what you want. And sorry, there's a problem. So simply we got that error because we have here the name, so you have to change the name. Please make it utility schedule. Okay, and get the hourly profiles as you want. Okay, and here profile 2, just showing you how to do it, and then you can click OK without any problems. Also, for the assignments, I have talked about the assignments and how to fill these things for the energy analysis. I have showed that in the at the beginning of the course in when I was showing the weather. Okay, and also for my tutorial about an introduction to energy analysis. So please, you have to get these things again. Also, you can click F1 and 2. You have to know how to do these things. Okay, so very simple. Just click OK. And also you can make emissions analysis for the complex type. So now for the energy charts, we have type of energy chart, standard or compound. Here the HAP manual, but it's in Arabic for the engineer Osama Atif Khayata. This is not my manual. This is the manual of the engineer Osama. So we have here, sorry, this is in Arabic, but I'm gonna tell you what's going on. Here we have many ways for the bills all over the world. So the designer has to get the optimum way for his project. Okay, so we have here the flat pricing. If the price of the energy is fixed all the time, or for some periods of the time, okay, or the year. So we have here the flat price. So click on energy. We have here energy because it is a standard. For the season, you may make it all seasons or for the summer or winter, like exactly what we did here. Also, if we make this, you can define summer or mid-season or winter or all seasons. Okay, so for the period also you can make it peak or mid-peak or normal peak or all periods here if you have a table. If you do not have these things, you will find here all seasons and all periods. So for the block size, what is the block size? So suppose that we have a kilowatt hour during summer billing months is like this, dollar per kilowatt hour, okay? And all kilowatt hour during winter billing is like this. So suppose that you will consume 40,000 kilowatt hour during the summer. During the summer. So HAB will do this. Kilowatt hour range all the block size 40,000 kilowatt hour multiplied by the price per the kilowatt hour, and you can get here the total cost. So how to do this here? For here, the summer and winter, okay, here for the summer, okay, L periods would not have schedule for the block size. Here we put 7 nines. This means that it is fixed. Okay, this is for the HAB. Okay, for minimum one or maximum 7 nines. Here the block size. This means that the price is fixed. Okay, for all the periods during this summer. And you're in kilowatt hour or kilowatt hour per kilowatt. So for here kilowatt hour, and here how much dollars? 0.077. Okay, like this. 0.77 for the winter. No, winter, all periods. If the price is fixed, you have to make these nines kilowatt hour, and how much it will be 0.049. This is the price through the winter. Okay, so if you don't have anything else, you can click okay, or go to the demand charts. Okay, suppose that you do not have fixed charge, okay, or fixed price, sorry. So you have to make this. Suppose that you have the same 40,000 kilowatt hour, okay, but the price is different. So for the first 8,000 kilowatt hour, this is the cost, and for the next 15,000 kilowatt hour, this is another cost, and the other remaining, all remaining kilowatt hour, this is another cost. So kilowatt range here, and here the price, and from 8,001 up to 23 thousands, here the block size, and this is the price, and the other kilowatt hour up to 40, this is the total cost, 40,000, here is block size, and here the price. Okay, so how to do this? So here all seasons. Okay, suppose that you have here all seasons, and here all periods, of course. So here the block size 8,000 kilowatt hour, and here the dollars, and 15,000 kilowatt hour, and here the last step you must make it 7 nines to tell HAB that this is the total, or this is the final step. Okay, and that's it. So, gentlemen, again, please. So, yeah, if you have here 40,000 kilowatt hour as a consumption for the energy for 1 month, okay, and you have for each block you have dollars per kilowatt hour, and they are different from the other sizes. Okay, so you have to make it like this. So this is if you have for a month and it does not change. That's why we make it for all seasons, but for each block you have a different dollar per kilowatt hour. So another thing here, if you have kilowatt hour per kilowatt, not per kilo, not kilowatt hour like the previous example. No, we have here kilowatt hour per kilowatt. What we have to do is here, gentlemen, the consumption is kilowatt hour per kilowatt, but this is for not all periods. This is according to the month, okay? So, gentlemen, what if we have here a demand? So according to the demand, we have another cost. So this is like what we have just said, but here is per kilowatt hour per kilowatt. Okay, kilowatt hour by kilowatt. So suppose that for a month we have for the first 150 kilowatt hour per kilowatt demand, here is the price, and for the next 100 kilowatt hour per kilowatt demand, another price, and for the additional kilowatt hour, here is the demand. I'm sorry, here is the price. Suppose that we have consumed 200 kilowatts against 60,000 kilowatt hour for 1 month. So the bill will be for the first kilowatt hour range here is from 1 to 30 thousandths. Here the block size, here the price. Yes, and from the other range and the block size and the other cost, and for the additional or the remaining the other the third cost. How do we do this? So notice that we have here also standard, all seasons and all periods, okay, and here block size and the block size, and so the block size kilowatt hour per kilowatt, this, okay, and here is 100, okay, and its price, and the last step for this energy, okay, it has to be 7 nines to tell HAP that this is the last thing and this is the additional things, okay, and that's it. So this is for the standard and for all seasons, and this is the total cost for month. شهر واحد, it means 1 month. So now what if we have a standard, but we have sometimes kilowatt hour and sometimes we have kilowatt hour per kilowatt, okay? Suppose that the first 150 and 50 kilowatt hour per kilowatt demand, this the price, and the next 15,000 kilowatt hour, this is energy, this is the price, and for next 100 kilowatt hour per kilowatt demand, another price, and the all additional kilowatt is this price. So here is the total cost is 120 kilowatt per 15,000 kilowatt hour. So this 15,000 kilowatt hour per 120 kilowatt. So the bill cost is, so here in the range, this is you have to multiply 120 by this to get the block size, and here is the cost, and the next 15,000 is this cost, and then multiply this by this to get the kilowatt hour, and the additional it will be 5,000 kilowatt, and here the price. So this is for 1 month, that's why we have here for all season or periods, and here is the method, okay. So now gentlemen, if we have a compound type of energy charge, suppose that you have sometimes energy and sometimes demand, okay, you know here the standard, you can make it kilowatt hour or kilowatt hour per kilowatt, like what we have just said. But suppose that we have compound here for the energy and it may be for demand. Okay, so ladies and gentlemen, for the compound block, suppose that we have for the first 125 kilowatt hour per kilowatt demand. For the first 3,000 kilowatt hour, we have a price, and for the next 87,000 kilowatt hour, we have this another price, and for the all additional kilowatt hour, another price. And for the next demand, 200 kilowatt hour per kilowatt, we have here another prices for each kilowatt hour. And for all over 325 kilowatt hour per kilowatt demand, we have here for all kilowatt hour, we have another price. So suppose that we have a consumption, total consumption, 500 kilowatt against here, gentlemen, this is not 20,000, this is 200,000 kilowatt hour. This is here a problem. Also, you can check out of that. You take F1 and compound and applications discussion. Here all the examples that I have just shown. So for the compound, notice the same example here is 500 kilowatt and 200,000 kilowatt hour. Okay, is used. So here, I'm sorry, the book has a problem here. So whatever, no problem. So the first 125 kilowatt hour per kilowatt, we have here the block size, multiply 500 by this, okay, to get the total kilowatt hour. So we have the first 3,000, and then from here to here another price. For the next 200 kilowatt hour per kilowatt, we have here the total, and from 1 to 6,000 price, and from 6,001 and up to 100,000, we have here another price. So all above 3 to 5 kilowatt hour per kilowatt, we have here another price. So this is the another price from the total 200,000 kilowatt hour. If you make a summation of all the kilowatts, you will get the total. So here, gentlemen, how to input the data. So the demand, the first demand 125, here the block size for all periods, all seasons, and the first energy here 3,000 as a block size, as you see here. Okay, and here for the next 87,000, there is another price, and for the all the remaining energy here or additional energy, you have to put this price, and because this is the last energy for this category or here is you have to put 7 nines. Okay, and for the next demand 200 kilowatts, the first kilowatt hour 6,000 here a price, and here for the next, okay, for the next you will find here 85 kilowatt hours, and here according to the HAP, or so the manual, he used 95,000 kilowatt hour according to some calculations. Okay, then here for all additional kilowatt hour another price, so you have to put this 9999. Okay, energy. Then the last demand, we have here the last demand for above or all over 3 to 5 kilowatt hour per kilowatt demand, you have for all kilowatt hour this price. So you will find here demand, and this is 999. This is, I think, because this for all over. Okay, and here the energy, because there is only one, I think we have here, this is for all kilowatt hour remaining. Okay, for all kilowatt hour you have to put 9999, and here the price. Okay, so now, gentlemen, if you wanna make demand charges for peak, mid-peak, or normal peak, and for all seasons or summer or winter, you have to get this tab. And here, modeling utility rates demand charges. Demand charge is imposed for the peak power used during a month rather than for total energy consumption. Utility companies typically impose a demand charge in addition to the energy charge. While nearly all electric and fuel rate structures contain an energy or fuel charge, only certain rates include demand charge. Demand charges are simpler than energy charges in that there are only two types. Each is described below. So, flat price, here the demand charge structure uses a flat cost or demand for all times or specific periods such as seasons or time of day periods. So sample utility rate statement. So if all kilowatt of on-peak demand during summer months is this, or kilowatt of mid-peak demand through summer months, another price, or kilowatt here on demand during winter months is like this. So here is how to get the total by hand. Okay, so here all here block size during one summer billing month, demand on peak hours is 370 kilowatt, and demand for mid peak is 207 kilowatt. So the demand charge is calculated as, so find here 370, and here's the price and here's the cost in 207. Okay, and how to get this in the program is like this. So I have here the summer is peak, and here is mid peak. Sorry, here we have a problem. It's not here mid season. It is only always also summer. It's a problem here. Okay, so we have here a summer and winter. But the summer we have peak and mid peak. The peak has a price, and the mid peak has another price, and it is fixed. That's why we have here 9999. Okay. So if we have stepped, so this pricing structure uses different demand prices for successive blocks or demand. This pricing structure is similar to the declining block energy charge. So the simple utility rate statement, suppose that we have here for the first 50 kilowatt of billing demand, this price, the next 100 kilowatt of billing demand, this price, for all remaining billing demand, another price. So here is the range. Okay, you can do this by hand, and to the input of the in the program, the number of steps entered in the demand charge is determined by the number of steps blocks in the demand charge. In an example, 3 steps are required. So all seasons, all period, block size 50, 100, and here the last step, and here always on kilowatt, and here the price like this. Okay, so exactly like we see here, all periods, all seasons. So gentlemen, it's according to the project or the example you have. You have to get the range, you have to know it's all seasons or summer or winter or whatever, the period, all, or the peak, mid peak, or peak, and so on. Okay, so now we have here another options for demand clauses. You can use them. So demand clauses here a ratchet clause introduces a penalty for large changes between monthly demands. So, example, a ratchet clause might specify that the billing demand shall be the measured peak demand or 80% of the largest peak demand in the preceding summer months of June, July, August, and September, whichever is greater. If the measured peak demand in any month is less than 80% of the summer peak, the 80% summer peak will be used instead of the measured peak to calculate demand charges for that month. Therefore, changes in peak demand of more than 20% of the summer peak will be penalized. So here, multiplier 80%, and here the peaking month June to September, and applies from January to December. What does this mean? So the final ratchet clause mark, okay, the box king months define a group of months during which the largest peak demand is identified. Typically, the peaking months will be summer months when the highest demands during the year are expected. Note that this specification is inclusive. So, for example, June to September includes June, July, August, and September. Okay, here, peaking months. They're peaking months, not the king month. I'm sorry. So the multiplier is the multiplier factor applied to the largest demand found during the peaking months. In the example above, 80% was used as a multiplier. So applies to defines the group of months during which the ratchet clause applies. In some cases, this will be all months other than the peaking months. In other cases, it will be all months of the year, specify January to December. In this case, as with the peaking months, this specification is inclusive. Okay. Okay, like this. Also, the trailing window. So trailing window clause introduces a penalty for large changes between monthly demands. It does this by comparing the measured demand in the current month with a percentage of the largest demand in a number of preceding months. Example, a trailing window clause might specify that the billing demand for each month shall be measured peak demand or 75% of the largest measured peak in the previous 6 months, whichever is larger. So, for example, to define, okay, mark this box. Here are the window and the multiplier. So in the window, the number of the prior months specified in the clause. In the example above, the window was 6 months. So note that the clause specifies in 12 months, a value of 11 should be entered. Why? To include the other months in the year. When performing an energy simulation, we are only working with a 12-month period. So excluding the current month, there are only 11 other months to consider in the trailing window calculation. Following the multiplier factor is applied to the largest demand found during the series of previous months. In the example above, 75% was the multiplier. Okay. Also here, the power factor. So the power factor introduces an indirect charge for excessive reactive power use. It is only used in electric rate structures. Power used in alternating current circuits is classified as working and reactive. Apparent power is the vector of sum of working and reactive power. So working power can be measured by a wattmeter. Reactive power is used to generate the magnetic flux in inductive machinery such as electric motors. Must be measured with separate metering equipment. Rather than measure it directly, utilities sometimes spot check buildings and impose a penalty if reactive power use is excessive. So the reference value for the penalty is the power factor, which is the ratio of working power to apparent power, and therefore indirectly indicates the magnitude of the reactive power component. The lower the power factor, the larger the reactive power use. So, example, a power factor multiplier clause might state that the customers shall maintain a lagging power factor of 90% or higher. For each 1% by which the average power factor lags below 90%, the billing demand shall be increased by 1%. So, that's why to define a power factor here, mark checkbox, okay, the multiplier of a building's power factor is 85%, lagging in the example above, then a multiplier of 1.105%, 105% would be used since the power factor is 5%, 5 percentage points below 90%. So this is the power factor, and here the minimum demand. So utility is often specified that the billing demand may not be less than a certain demand level. For example, minimum demand clause might state that the billing demand shall be the measured peak demand or 50 kilowatt, whatever is larger. So to enter, mark the box and then enter the minimum value. In the example above, the minimum demand was 50 kilowatt, okay? But here 35, okay? So, but you have to make it, I think, 50 kilowatts. So you have to know exactly what is the minimum demand. Okay, so you have to get the minimum demand here, kilowatts. Also, the demand multiplier clause. This type of the clause typically provides a discount for demand measured during certain times of day or times of year. This is done to encourage shifting of demand to those periods. Example, demand multiplier clause might state that billing demand during the winter months shall be 60% of the measured demand. So I have to put here 60% and the winter and your periods. So here the season, you have to select what you want, winter, summer, or mid, or all. Okay, if seasonal schedule was not specified, all will be only choice. And here the period, you have to know which period, and so the multiplier factor applied to all measured demands in the season and time of day period covered by the clause. In the example above, season equal winter and period all and multiplier 60%. Okay, ladies and gentlemen, this is the end of the electric rate. Just click OK. Now we're going to talk about the fuel rates. The fuel rates are, I think, the same. So here I have simple and complex. So the simple here, we have energy units, therm, click F1, you can change them and you enter a conversion factor relating the units of the measured standard energy units such as kBTU or kilowatt hour. You have to know that a therm equals 100,000 BTU or 100 kBTU. kBTU. What about therm? You have to know the conversion. So again, one therm equals 100,000 BTU or 100 kBTU. So it's 100 kBTU. Okay. So here simple and the same thing that we have said about the electric, you will find it here again, but here the complex, here the dimensions, it may be hourly peak or daily peak. You can define what you want. Also the seasonal scheduling, the time and emissions are the same. For the fuel charges also we can make what we have said. You can find here it's the same thing, but you notice that there are basic rules. You can for the electric you cannot, in the electric, when you define the electric rates, you cannot make overlapping between the periods, I think, but in fuel it's okay. can get these things from the basic rules. Okay, so gentlemen, you have to know these things. So here, gentlemen, the basic rules in simulating heat. Uh, Basic rules, please. You have to read carefully the electric energy charges and how to avoid the overlapping. And here is the field charges. Okay, so overlapping demand prices are permitted, and overlapping energy prices are not permitted. You can see everything here. Okay, so after finishing, I opened this electric, and here are the fuel. Okay, okay. Suppose that you have finished, so please you have to click OK, and you will find here your flow rates. Okay. Okay, ladies and gentlemen, this is my tutorial. I think it is somehow it may be complex for the first time, but you have to read many times about this energy analysis from the F1 help. Okay, to cover these things again, the next tutorial will cover the plans. So we have defined the boiler and the chiller, but we're gonna talk about the system that needs cooling tower here, the plants that needs cooling tower and these things. And after finishing that, we're gonna talk about the buildings and how to generate the simulations for the energy. Thank you very much. Assalamu alaikum warahmatullahi ta'ala wabarakatuh.